everybody. Welcome along to this week's Sandbox session. We've got an absolute treat in store for you, actually. It's definitely one that I've had circled in my diary in terms of been looking forward to. So just before we get into that, just a couple of very quick announcements, and then we'll welcome Michael to the stage. So first of all, in terms of thanks, we've had a great month of events in February this year. The company logos that you can see in front of you have been some fantastic partners across the month. They've really shared some awesome content. We've had some great engagement, and today is going to be absolutely no different with Michael from Product Madness. So massive thanks to all of those companies. In terms of upcoming events, just something to perhaps keep an eye out for. Next month, we're running an event with Databricks. We're going to be launching that in the next week. So if you're keen to keep up to date with that, by all means, just join the mailing list, keep an eye on the website, and go from there. So in terms of today's session, I would love to invite Michael Leznik to turn on his camera and microphone, please. And we'll give a bit of an introduction and talk about what we're going to cover today, Michael. So hello, good sir. How are you doing?
Thanks for having me, David. Thanks for having me. I have turned on my microphone and camera.
It's a good start, man. It's a good start. So I don't know if you're like me. I've got a whole team of like makeup and hair. You know, they do all that stuff for me before I join the webinar. So I'd imagine it's been the same for you today, hasn't it?
I just out of hospital, last plastic surgery.
Yeah. You're looking good for it, Michael. You're looking good for it. So I'm actually just going to stop sharing my screen so that the people at home can see us a little bit bigger. In terms of today's session, Michael is the VP of Data Science at Product Madness. 15 years of experience in terms of delivering data projects, leading teams, basically making stuff happen. So we're very lucky to have him here today. And the aim of the session is very much a fireside chat. So we've got some pre-prepared questions. We're going to delve into how to structure the team, what to look for when you're joining a business, how to get the best out of data scientists, what is a data scientist, all that sort of stuff. So we're going to hopefully make that conversation flow. Equally, it is an interactive session. So if you're watching along at home, you have a question, we're keen to hear from you. Drop it into the Q&A, and we will do our best, obviously, to fire in some questions from you. In terms of kicking things off, Michael, I've given a very high-level overview, 15 years of experience. I should probably tell everyone at home, I've got a very strong feeling you'll give us your straight talking approach, which is why I had it circled in my diary. But if you could perhaps tell us a little bit more about your background and experience, perhaps just to set the scene, to let people know a bit more about you, and then also why you were so keen to be involved in a session like this today.
So thanks, David. So a bit about me. So 15 years it's experience here in London, actually. So prior to that, I mean, you have quite a long, many years story of different startups and different products in Israel, and so overall together probably close to 30 or something like that. But yes, so why would I want to talk about it? I mean, my 15 last years of being involved with something that's called data science, probably 10 of those years were something that's called data science, and prior to that, the data science term as such didn't exist, but the job was still there. So the nice question is, how did we all do without the job data science, but still doing the same things? And prior to that, obviously working with as a developer, as a quantitative developer, as it was called back then, also doing pretty much the same things. So it's quite interesting to see how the whole sector of economy, how all this area has evolved into something absolutely different. They will touch upon different things. So yeah, I think it would be nice to share what I know. Some might agree, some might disagree, but that's definitely a good start for conversation.
Exactly that, man. Exactly that. And as mentioned, it is a conversation. So I might regret saying this, but equally, if you disagree, fire that into the chat. Let's have a Q&A and see what happens. So you've mentioned, obviously, you've been doing it 10 plus years as, data science. And I think, myself included, last 5-6 years, I've been heavily involved in the data science community, but it has been around for a long, long time, perhaps called different things, but it's been data science. So in your opinion, what is a data scientist? Who is a data scientist? And what does that look like in your opinion?
Yeah, so that's an interesting one. So let's start from the fact that, and that's might sound like a disappointment for somebody who might wants to become a data scientist. So the data scientist as a term is a huge misnomer. So it's a big umbrella around many different things. And if, let's say, 10 years ago, you would say data scientist, you would look at somebody who can, I don't know, who can model something, I don't know, maybe back then in R. And then 5 years passed by, you look at data scientists who can model something, who can develop maybe some machine learning algorithm. And then you continue. And now today we arrive to the point that, for instance, Netflix alone recognizes 9 different jobs under the umbrella of data scientists. So 9 different, so the granularity is growing in the area. So when you are saying data scientist, you would most probably need to explain what type of data scientist you are. So let's stay first of all in the generic term. So data scientist technically isn't, why it is misnomer? Because science doesn't exist with data, and so any scientist actually have to work with data. So there is no specific data scientist who is, I don't know, doing some specific action on some particular data. So data scientist can be biologist, can be mathematician, can be physicist, can be statistician, can be economist. They're all in their way data scientists. The question is as to what area their knowledge is applied. So technically nothing new here, scientific methods, you have an intuition, you set up an experiment, and if experiment proves your intuition, no matter how crazy it is, that must be true. And that's not said by me, that's said by people bigger than me, rich and famous definition of science. So that's pretty much the same for data science.
Agreed. And I think that's the thing that you see most often, is it? Everyone seems to aim for this data scientist job title. And actually, you have to be quite clear about what's involved. And I think sometimes organizations can be guilty of that as well. We need data scientists. Well, let's be clear about what data scientists you need. So I guess kind of keeping that conversation going around organizations, and we kind of have talked in the past about data-driven organizations, or perhaps more sort of data-friendly organizations. And is there anything that you think perhaps people or candidates need to be aware of when they're joining a business? What's the difference between data-driven and data-friendly, and is there anything to be aware of there?
Yes, definitely. So let's try first of all. Yes. So what does it involve to be a data scientist, and what does it mean to be a data scientist? So under that umbrella of Netflix, which is called data science, they have business analyst, data analyst, quantitative analyst, algorithm engineer, analytics engineer, data engineer, data scientist, machine learning scientist, and research scientist. So here you go. Wow, so many different things. And they are all different things. They are absolutely all different things. And any organization when they decide to start something like a data science in their org, they definitely need to think what it is that they want, because it's not all the same. There is this feeling sometimes that, oh, let's bring a data scientist, they will do crazy things, they will help us, and yeah, sure, they do crazy things. But then again, here we come, what org you are. Are you ready to work with data? So in our industry, technically, we recognize what you rightly said, data-driven and data-friendly. So the difference is something like this. You can say data-friendly is that the org, which has got some sort of data infrastructure, and they do look at data. They might make some sort of decisions based on the data, So they're aware of data existence. They are friendly to their data. So that would be data friendly. And data driven is the org that actually makes all their decision making based on the data they have. They look into tomorrow. They don't look only on what happened yesterday. They also look into what's going to happen tomorrow based on their data. And they make their decisions and they make their plans based on the data they have.
Perfect. Yeah, it makes a lot of sense. And I guess if you're an aspiring data scientist or an established data scientist and you're looking at joining a business, I guess you would advocate moving towards that data-driven business over a data-friendly business.
So yes and no, depends how adventurous you are and how much change and transformation you want to drive. Because I mean, you can come to a data-friendly org and you can help them to become data-driven, or you can come to a data-driven org and get quite a lot of experience on how does it work. So it would depend, but in any case, you need to understand what you're stepping into, because in data-friendly org, everywhere data scientists have to, I'm not saying sell, but they have to present, they have to convince, they have to demonstrate. But it might be easier in data-driven org than, for instance, in data-friendly org.
Okay, and if you were interviewing and you've got to that final stage and you're asking all your questions and deciding where you're going to make your next career move, what is it that you would ask to determine whether a business is truly data-driven as opposed to being data-friendly? Because I think most companies out there nowadays are data-friendly. They're aware of it. They're using it to make some decisions. What is it that sets it apart for you? What would you ask to find out if a company truly is data-driven?
So obviously, the one reason why people have today data scientists and data-driven org, so what they do, they define the truth within org using data. Okay, yeah. So this is our main job. I mean, what we are doing is that we are technically helping to identify what the truth is. I mean, we have statistical methods and under certain conditions, under certain way, helping to identify what the truth is. So if you ask those questions, you can ask how many decisions were made based, how organization makes decisions making, how much data is involved, what was the biggest project that data science had done, what in this org, what impact data science so far had on the org. So from all those questions, you can understand how much this organization actually is data driven or data friendly, and what you are doing. So these are the important things to identify.
Makes sense. Perfect. Thank you very much, Michael. I think in terms of people on the call, I know we'll have some people that are building a career, different stages in their data science journey. They may well have some questions about how to get hired or what's important in your opinion when building that career. I do know also we'll have some people on the call that are perhaps managers or leaders or founders, and they're looking to build data science teams. So I've got a couple of areas of questions that I'd like to explore now. The first one, I'm going to perhaps talk about how to build a team, how to hire data scientists, and then after that we may well go on to talk about how to get hired as well. So I'll maybe kick things off. You've obviously got lots of experience, particularly in your current role. I know we've talked previously, you're building, constantly hiring people in your current role. So have you got, what's your view on how to hire a data scientist? And I guess also understanding, based on what you were previously saying about these 9 different profiles, how do you actually understand what you need? So have you got any tips or views on that, please?
Yeah, sure. So I happen to help in my previous job. I happen to help build data science org for King, the maker of Candy Crush Saga, where I helped to hire around 70 data scientists and probably interviewing something close to 300 something, if not more than that. And then I helped here in Product Madness to build another data science org of 20 plus data scientists. So definitely I have been exposed to the process of building and hiring orgs, building data science orgs and hiring. So when you hire a data scientist, so the first thing you need to understand what problem, like everything else, what problem you're trying to solve. And then after I understand what problem you're trying to solve, then you start to understand what type of data scientist you need. Maybe you need to build a pipeline to help pass data from your products to your data warehouse. So probably in this umbrella of data scientists, you need data engineer. So you don't really need somebody who is actually going to model, or maybe you already have the data and the pipeline fields and you want to make decisions and you want to build dashboards. So probably you would need a BI analyst, business intelligence analyst. And they also sound quite often come under umbrella of data science.
Mm-hmm.
And then after you created all the infrastructure, then you want to make decisions, and you might need an analyst, you might need BI analyst, you might need data scientist. Very important to understand the difference here. And what I like how I explaining to them, I always say BI analyst is somebody who tells you what happened yesterday.
Mm-hmm.
Data analyst is somebody who tells you what happened today.
Mm-hmm.
And data scientist is somebody who's going to tell you what's going to happen tomorrow. Tells you what happens tomorrow. So now in a more maybe mathematical way, so data analyst dealing with everything what is linear, with everything what you can get from the database, from data warehouse, quickly provide analysis, present data in the right way, build a scope for the further work for data scientists, for a modeler who will take the data and make of it sense for tomorrow.
Yeah.
So those are the differences, and this is where every org, when they start to do things, they need to understand who do they want, because quite often what happens is that they say, oh, okay, great, you hired this guy who's got PhD in maths, and then this guy comes, or a girl comes over to the org, and there is no data, or, or nobody even knows what to do with that data, and then this person sits there, and then half a year the org is disappointed, and the person is disappointed.
Yeah,
they go to their own ways.
I think it's a common story. It's a common story for sure. So I guess I've got two follow-up questions for you there. And we do sometimes work with companies, and I guess you've been in the lucky position where you've been in a big organization, Michael, and perhaps in a smaller company, it's hard for them to hire the 9 different profiles. So they'll try and hire one person that can do it all, the mythical unicorn that they're trying to find. So I guess in terms of that, first of all, do you think one person can do all of it? If they can't do all of it, is there parts of it where there can be crossover and you can expect one person to do both? So do these unicorns exist? And what would you recommend if you can't find a unicorn?
So yeah, that's a great question. So the unicorns are kind of in this case they're like dinosaurs. They're going and disappearing because, as I said, Netflix has got 9 different jobs being a data scientist. So in a good old days, you would quite often have a person who would be kind of sort of data engineer who knows how to analyze data.
Yeah.
But it's going and disappearing also. So if you're in startup, you can try to find a unicorn or somebody who is enthusiastic of being unicorn or look like unicorn, but eventually you will have to separate these things, and sometimes what I call the power of 2, and some people even say power of 3. So for every task you create, you have a data science engineer, you have a data scientist, in this case, the person who can work with context with data, who understands the business problems of it. Mm-hmm. And then you might have somebody who might create a machine learning model or something. And then you would need another person today who would put this machine learning model into production.
Yeah.
So that this is, and the one important thing to realize here is that today those people even study different things.
Yeah.
That you would have regularly you would have a computer engineer, computer developer, computing engineer who would be able to do all the computing related programming tasks, or maybe putting code into Python into some production area, or using AWS cloud or Google products. And then you would have a person who knows math very well, or biology, who can do modeling, who can understand statistics. So all those people, they are different people. So unicorns, yeah, they might exist, but still, you might have a good crossover, but at the end you will need it. You will need to separate.
Yeah. Makes sense. It makes perfect sense to me, for sure. I guess carrying on the conversation from that perspective in terms of the team structure and defining who you need to hire, and you kind of called out, you know, there's a BI function, there's data analysts, and there's data scientists. Quite often I'll talk to a company, we need to hire a data scientist, and when you drill into the detail, it's actually a data analyst they need. So it may be an impossible question to answer, but you know, in terms of percentages, you know, would you kind of say, you know, 50% of the time it's BI, 40% of the time it's data analyst function, and then only like 10% of the time you need to build like actual models and machine learning and stuff like that? Or?
So I would refrain to give a percentages. At least what we are doing in Product Madness is that we are clearly trying to define who is going to be data. Are we hiring data scientists or are we hiring data analysts? So we hope that they are all 100% busy with what we want them to be busy. So, but and we separate. But you know, in the good old days, they would have said that 90% of the time you are cleaning up the data, and 10% you are building of the time you are building an algorithm. So in that case, maybe, you know, for every 2-3 engineers, you might need one data scientist. Something like that.
Makes sense. Makes sense. Thank you. I think as well that I'm freestyling a little bit, Michael, but you probably probably knew I was going to do that. So I think one thing we see with speaking with candidates, even people within the community, you know, they all aspire to be this data scientist, and they want that job title. And actually, sometimes they'll look at it and say, oh, I don't want this data analyst role. I don't want to be a senior data analyst. I want to be the data scientist. And whether it's the same job function or not, they just want the title. So in your team, in your opinion, you know, being a data analyst or a really good senior data analyst is just as important to the organization and drives change. Yeah.
Absolutely. I mean, the one have to realize, as I said, data analyst answers the questions of today, and data science answers the questions of tomorrow. So you need to create an information flow in your org between the stakeholders, data science. You need to clearly have this way of formulating the problems and giving them to data science. Data science obviously have to know context. But the data analyst is a very important person. Data analyst is the person who is holding this, who is sitting in the middle. He or she, they know business, they have the whole context, and they can formulate. Quite often people, I mean, you know, in mathematics, they say, like, I mean, the highest level of mathematician is the one who can create the problem, not solve the problem. Yep. So data analysts are people who actually can create or formulate the problem quite often for data science, because and this is very important. A very good data analyst is priceless.
Mate, it turns out I'm a genius because I'm always creating problems. So
here you go.
I didn't realize how clever I was making these problems. So awesome. We've actually got 9 questions in the Q&A. So this is obviously landing very well. There's a lot of engagement out there. I'm going to just fire into this one next question that we kind of highlighted in preparation, Michael. And it's quite to the point, how to get hired. And I think a lot of these 9 questions are looking at them coming from people, you know, where do I get started? Have you got any tips on these different areas? So perhaps we'll just come to you with that broad how to get hired and get your opinion on it, and then we'll maybe jump into a couple of questions from there, if that's okay.
Sure. So obviously, like when the org decides what problem they want to solve, I mean, the candidate who's hired have to decide what do they want to be. I mean, what do they want to do? Do they want to do data engineering? Do they want to do data analysis? Do they want to be, or they want to be a data scientist? Obviously, they need to look at their skills. I mean, do they have skills required to be one all of those things, which is very important. But the one thing is, I mean, when you go to the interview and you send your CV, and this might be quite a few generic advices, but be prepared to talk in details about your CV. I mean, you know, these days of the I believe that these days of the, if you remember some 10 probably years ago or something like that, Google was firing all those kind of random puzzle solving questions in the interview, and then they have decided that's it, we are not going to do that anymore. We are not actually testing anything with that stuff, and that's rightly so, because so be ready to demonstrate. If you want to be data science, be ready to demonstrate that you can understand context. Be ready to demonstrate that you know how to apply different statistical methods to that context. Be ready to demonstrate that you know what methods, what they are and why they are needed. And most importantly, be ready to talk about those things. I mean, quite often in depth, don't be shy to demonstrate what you know. Okay. You know, that's important. And again, I mean, I'm not saying that it's everywhere, but quite often people write CVs and you read them and it's like, wow. And but if you put something into your CV, so be ready to talk about it. Yeah. Because if you put something into your CV and then when you get a question and say, hey, yeah, but I did it a long time ago, I'm not sure I remember, then it's not gonna work. I probably still can discuss my PhD work in a very little detail. I had it 15 years ago. So yeah.
Makes sense. Makes sense. Yeah, but you've got to be prepared to walk the walk as well.
Walk the walk. Yes. Walk.
In terms of that, then you were talking about being very detailed and talk about specifics. Does it also help, in your opinion, to say, well, I built this model, it improved accuracy by 7%, which increased customer retention by 1%, which earned us an extra £300,000 a month. So coming back to that end result of, I did this, it benefited the business commercially in this way. Do you think it's important to demonstrate that in an interview, or are you more keen to see this is how I did it, technology side of things?
So when somebody tells me about, hey, I did this, I did that, and so when I interview people, I try not to ask questions that they don't know. Mm-hmm. So this is kind of an advice for everybody. So I always trying to talk to people about things that they should know. Mm-hmm. So if I'm asking a question, I will start from the lowest common denominator between us. And I'm talking about people. So what's your most favorite project that you have done in your working career? So let's talk about it. And it's your most favorite project. So you should be able to talk in details about this project, because this is the best thing you have done. You like it most. So you can say, hey, this is what I built, and this model has improved 7%, and it brought this. That's great. But then my next question would be, okay, so how did you improve this by this 7%? Did you change algorithm, or did you change context? Did you change data? What did you do to it to be 7%? And this is what's important.
Okay. Yeah, makes sense. So I feel like any candidate going for a role at Product Madness is going to have to watch this webinar in advance to make sure they're well prepared.
I think any candidate going to be hired as a data scientist can answer this question, should answer these questions. I mean, look, I mean, there aren't many things that you can interview. I mean, you can interview about stats, you can interview about maths, you can interview about the engineering part, or you can interview about some technical skills. But one of the most important skills that you can demonstrate in the interview is your ability to learn.
Yeah.
And the way to demonstrate ability to learn is to show that you have learned something.
Yeah.
And the only way to show that you have learned something is to know something in a very little detail, because you learned it.
Yeah. Yeah, and have the passion for it, for sure, for sure.
Yeah.
Okay, I'm going to jump into a few of these questions. We're now up to 12 questions, Michael. You'll be pleased to know. So I'm going to try and, there is quite a lot in there, so I'm going to try and pick out a couple of ones based on what we've just been talking about, role functions, how to get hired and stuff like that. So the first couple I'm going to come to are going to be based around that. So there's been a couple of people asking questions about the difference between being a machine learning engineer and a machine learning scientist and a data scientist. So have you got an opinion on how those, what the differences are for you in terms of those role types?
Yeah, that's a very interesting question, and I understand why people ask it. So in quite often that would be it would be important what type of technology stack company is using. So for instance,
Okay.
if your company is fully on cloud, so your separation between the machine learning data scientist, the person who puts the model, who creates the prototype, who learns the business problem, and machine learning engineer who puts it into production on AWS, SageMaker, or Google-related AI products. So those might be different people. Those might be, one of them are more computer engineers, the other ones are more mathematicians. But every company and everybody should learn to recognize that there is a difference, that there is no fire and forget here. When data scientist builds model and this model is deployed on the cloud and somewhere else, it's a product. It's a product that requires support. It's the product that requires maybe retraining, that requires many different things, which means that you need to support this infrastructure. And this is why you need data science engineers to do this.
Makes sense. Makes sense. It's getting stuff out the door as much as anything else, isn't it? So that perfect. Thank you very much for that. In terms of that, talking about that, you know, different skill set, ML ops, you know, being a machine learning engineer. Question that's come in here is, you know, how do you, well, you've already defined it actually, how do you define ML ops? And then they've said, what ML ops skills should a data scientist be well versed in? So, you know, if you were looking for someone to be, you know, involved in deploying, do you look for particular mindset, or do you look for them to have worked with a particular technology like SageMaker or whatever, in terms of that, you know, deployment process?
That would be important, how far you want your ML ops to go. I mean, if you want them to be able to train and retrain, do you want them to be able to? So the one thing you might find is that by moving your model from AWS to Vertex AI, you might find that the same model and the same code ported from one place to another, the same Python code will give you absolutely different results. So you might want your ML engineer to be able to understand why the results are different. Is it a shift in distribution, or there are different parameters which were used? Yeah. So they do need to understand what those models are when they're deploying them, and they do need to understand at least on some sort of, on a certain level. I mean, what are the parameters and why they are this and that. They must be able to retrain and provide the same results.
Yeah. So I guess as a machine learning engineer, you have to have an awareness of data science. And as a data scientist, you have to have an awareness of getting stuff deployed. So it is
deployed. Yes. Awesome. The data scientists should definitely know that there is a life beyond this R studio interface where they put their model with some data and the prototype is working. It doesn't mean that the job is done.
It's not all in a notebook.
It's no, it's not while it's in the notebook. Yes.
Perfect. I have a couple of people asking questions about either transitioning into data or data science or starting out in their career. So, you know, if you're speaking to a developer or a DBA that perhaps has experience, you know, working in tech, working with data, have you got any recommendations on how they could get started into data science?
So again, they need to choose what they want to start into. But the one thing that one needs to remember, and that's probably an important thing, and we are touching upon several kind of strings here that are close to my heart. So just remember that if you know what logistic regression is, it doesn't make you a data scientist. It just means that you know one of the methods of analyzing data. What is important is actually what data you are looking at. How do you understand your data? By moving from one algorithm to another, you can improve things by 3-4%. By actually changing your underlying conditions in data, changing the assumptions about data, you can improve things by 10, 20, 50%. So the gain is actually in understanding the data. So when you say data scientist, you must be able to work with the context, with the business problem, and being able to apply those statistical tools to this particular context.
Yeah. Again, makes perfect sense. Perfect sense. I'll just take one more sort of theme of question from these questions, and we'll jump back into some of our conversation, Michael, and we'll pick up perhaps some questions at the end if we have time. There's definitely a couple of people clearly that are watching along that are starting out. You know, they're graduates, and they're looking for that first job in data science. And I guess over the years, you're going to have hired principal level people, but you're also going to have been involved in building whole teams from graduates upwards. For those people just starting out, have you got any tips for them? Would you recommend an internship? Do you look for particular things in terms of their education, you know, to get their foot in the door? You know, for those people just starting on their journey, do you have any tips for them?
Sure. So the one thing which might be very important for your first job as a data scientist is that try to choose the context that is close to your heart. Try to find a company or place with data that you're gonna like, whether it's an e-commerce or computer games or gaming or any other type of program. Try to first of all, it can be delivery room, data or any other place, but try to find a place where the data actually makes sense to you, where you're going to solve problems that you're gonna like. Mm-hmm. Don't never think about it that because you know logistic regression or because you know how to do an A/B testing, you're going to go and apply it to any kind of data, whatever it is, and you don't care about it as long as you know. That's not true. If you want to really make an impact as a data scientist, try to find context which is close to your heart, and then obviously you need to know all those tools. So in a simple language, you have a hammer. So find a good place to stick that nail. Don't go everywhere because you might not like it. Being data scientist is not only sticking nails without thinking; it's actually where to stick those nails and what those nails are.
And I love it. I knew I was going to enjoy this one, Michael. Perfect. So we've answered 10 questions. We've got another 11 questions there, but we're going to fire through a few more of the kind of pre-prepared stuff we've done, and I think that will keep the conversation moving. So you've talked to us about how to hire data scientists. You've talked to us about how to get hired. You've got a bunch of data scientists. How do you make a team? How do you get the best out of them? How do you structure them? What happens next once you've hired all these wonderful data scientists?
So this is an important question, and this is obviously more question for people who are going to build for decision makers, for executives who want to have a data science. There are technically two models of data science sorts. One is central, and the other one is distributed. And both models have their merits, and both models have their disadvantages. But one needs to totally understand, one needs to understand what it is and how they're going to deal with it, because there is no ideal, there is no one model fits them all. There is no total ideal, and both of them will say, but let's try to talk about what difficulties you might have if you follow one or the other model. So if you have a central model, so what you might have, the positives are that your data scientists will be together, they will be sharing knowledge between each other, they will be talking, they will know about, but you immediately create an ivory tower. And quite often in the central org, data science is disconnected from the context of organization because they are existing by themselves. Moving to embedded structure, distributed structure, obviously you'll get your data scientist closer to the context and closer to the business problem, but you are risking to break the data science culture between themselves. You need to make sure that they're talking to each other, they're sharing the knowledge. They're not all of them, because they're sitting in different places, solving the same problem, for instance. So you need to have very, very strong functional management in this type of organization, which will make sure that your data science exists as a team and not as a bunch of people who are just embedded in this or the other part of organization. Because if you go like this, it's not going to work. And if you go 100% central, it's probably not going to work. So the truth is somewhere in the middle. The life is a game of optimization, and you need to think about it, what you need about it. But there are two models, and they both have their merits and disadvantages.
Perfect. I'm going to nail you for a specific though, Michael.
Okay.
You know, talk to us. Product Madness. How have you got that perfect blend How do you do things there? Do you have data scientists out embedded, but have a way of bringing them back centrally, of communicating, of sharing knowledge? What does it look like for you?
So what do we have here at Product Madness? We have, within data science, we have 4 different teams.
Okay.
So we have data warehouse, or data infrastructure team. So those are the people who are responsible to bring the data from a certain point from product to our data science data warehouse, where actually it will be consumed. We have embedded data scientists, which are working with each separate games.
Yeah.
Then we have central org, which is kind of looking at all games together. So if you look at it as a microecon, macroecon. And then we have machine learning team, which is looking at, everybody can build a machine learning model in our org, if there is a place for it. But the central team or team will be the ones who will make sure that it's sound, required, make sure that it's supported after it, and they will put it into production. So this is how it works. And then obviously we have once a week, we always have the lunch and learn sessions where all data scientists are presenting their work, discussing interesting things. This is important if your work is distributed, to make sure that you're sharing knowledge.
Yeah, perfect. I think it comes down to the culture of the organization as well. So by the sound of it, you're trying to build, or have built, that inclusive sharing of knowledge. Ideas come from everywhere, getting people together and being proud of what you've done. So
this is
fantastic.
This is very important, and it always works when you have people who love what they're doing, who love the context, who love their data, who love what they are. They're happy to share their knowledge. They're happy to share. And we have data sharing of data, lunch and learn sessions in data science, and then also we have what knowledge share sessions, is that when product managers, data scientists, and others share knowledge between 3 different orgs within the company.
Yeah, amazing. Sounds good. I know when we were talking previously in preparing for this session, we did also talk about the difference between cloud and on-prem. We did also talk a little bit about tools. So have you got anything to share in terms of those 2 points?
Yes. So there are still companies which are working on-prem. It still exists, but the trend is inevitable. We are all moving to cloud. And when you are moving to cloud, you need to realize, you need to understand that that data scientist that worked with this computer sort of, with this Airflow, whatever it is, that's it. That's not going to exist. I mean, now you are on cloud. It's a different product. It's a SageMaker. It's a Vertex AI. So you will need another engineer to support all these models. You will need another person who will deploy all this. So yes, cloud provides a lot of convenience, but it's also a different question in terms of people working.
Yeah.
And
very
tools,
good.
yes. I mean, we like our studio. We like our Studio Connect. This is one of our favorite things. But then also when it comes to machine learning, it all looks to Python, and it's not R anymore. So there are different things between the prototyping and deploying.
Amazing. And I guess one of the questions actually that had come in, I said we were going to cover our points, then go back to the questions, but I guess this is quite topical. You know, talking about that tool set, you know, if someone's just getting started, you want to learn everything. But obviously it's impossible. So, you know, what should people be focused on? Like learning really good, strong SQL to be able to query the data, and then picking either R or Python, or, you know, what would you recommend?
So yes, SQL is absolutely essential. I mean, you cannot be a data scientist without being able to work with SQL.
Yeah,
that's the foundation of everything. Yes. So first of all, yes, pick up a SQL, and then decide. R might lead you to, if you're a statistician, if you're more of a person who is working with A/B testing and type of kind of product-related data science things. So you probably will be more in R. If you are more on the machine learning side, you might move to Python, and this is where you will be required.
Perfect. And do you think that's, again, excuse me if it's a naive question, but is that a difference between the languages, or is that the fact that just because Python's more popular, there's more open source packages and stuff like that, you can just kind of plug straight in, or do you think there is a fundamental difference?
No, there is a difference. R is a more of a, there are things that you can do in Python, and there are things that you can do in R.
Of course, yeah.
And some might find it slightly heretical, but I, for instance, say that what ggplot does in R and the charts that you can create, you might create something similar and close in Python, but there is no need. I mean, ggplot covers everything. So if you work with product, you need to visualize quickly your results. Python is probably overkill. R is the best tool for it.
Okay, amazing. Thank you very much for that. And one thing that I was keen to touch back on, hearing you talk about it, was the power of 2. And I think I even heard you even mention the power of 3. So I think you briefly touched on it, but I was keen to learn a bit more if possible.
So what we call power of 2 or power of 3 even is the fact that when you are, there is no such thing like one data, as you said, unicorn. There's one data scientist that will do it all. You wanna solve the problem. You need the person, and today those are different skill sets. You need the person who can build model, and then you need the person who can deploy model, who can actually make out of model product. Yeah. And this is power. So you need an engineer, and you need a data modeler, statistician maybe. And the power of 3, you need the data engineer, infrastructure, who will bring data into data warehouse. You need a modeler, and then you need someone who will deploy that model into the cloud or whatever.
Amazing. And one of the questions there actually from Lamia, talking about, if you're a startup, especially in the case of growing startups, when you're bringing people in and hiring people, if you're on a budget and you've got to make 2-3 hires, I guess that is how you would approach it. You'd build a team of 3.
Yes, you would probably start from the data engineer to make sure that you have created data. Then you would bring a data scientist that you make sure that somebody analyzes the data, and then if you still need it, you would bring a machine learning engineer, where it is. Amazing. Or you take all 3 salaries, make them 1, and look for the unicorn who could do 3 things together.
No, don't get me started on looking for unicorns. I've spent far too much of my life looking for unicorns to do that. So just quickly, Jay and Athi has just dropped a quick message just to say thank you. They've had to drop off, which is fine. We completely understand. Obviously, we know you have meetings to get to and stuff like that, but thank you very much for saying thank you. It's really much appreciated. So the next 2 points, I think, were probably my favorite points to discuss, because as mentioned at the start, Michael is full of opinions. So point number 1, when I was talking with Michael previously, he was very, keen to tell me he doesn't like Kaggle. So I was keen to talk more about that, Michael. Why do you not like Kaggle?
So there is a lot of misconception about Kaggle, and let's jump a little bit back in history. I mean, if you remember, $1 million prize by Netflix, yes?
I do remember.
Yeah, it was very famous thing that where Netflix gives a data set and says, hey, if you build an algorithm that will solve this problem on this particular data set, we are going to give you $1 million. And that's ultimately, I mean, the funny thing is that problem was solved. They built a new algorithm, but Netflix themselves, even after paying $1 million, don't use that algorithm, by the way. So just a kind of secret in our industry that everybody knows. So what the problem with Kaggle? The problem with Kaggle is that it creates the misconception that you will go and apply algorithm to any given data set and you're going to solve it. And that it's just not how it works. It's just not like this. You can be a student and you quite often you say to people, okay, so I will apply XGBoost, and if XGBoost doesn't work, I will apply neural networks. It will improve it. No, that's not what it is. It's not about it. It's about what the data is. And the problem of Kaggle is that there is a given data set where you're gonna, okay, I'm gonna have this data set and I'm going to apply without learning sometimes even context of that data. That quite often don't even understand what this data set actually means. And people just go and apply this algorithm and that algorithm, and they're imprisoned by that misconception is that the work of data scientists is just actually juggling different algorithms between any data set that they receive. and this is very much wrong. This is not true. This is false.
Love it. Thank you very much. And it makes perfect sense, but I was definitely keen to hear you explain that one after I'd seen it on my bullet point. So just the final point in our pre-prepared questions, and then I'm conscious of time. We've got about 7 or 8 minutes left. So we'll discuss this last point, and then we'll maybe fire through a couple of final questions and draw things to a close from there. So intuition sucks, but it is important. Talk to me.
Yes. So when you work, particularly in the data-friendly org, you will quite often hear, "Hey, this is how it works. I know it works like this. I've seen my friend doing it like this." So quite often, the personal intuition, or what we call anecdotal evidence, quite often this becomes the argument in discussion. And so, from this point of view, the intuition sucks. I mean, your personal experience is almost in 100% cases is not the experience that your clients or your players or whoever it is are going through. So intuition is important to have a starting point, to have a discussion, but you need data, you need rigorously designed experiments to support what you're saying. So intuition sucks if you want to use only intuition and anecdotal evidence, but intuition is important if you use it as an important starting point to design experiment and to present your findings to establish the statistical truths.
Yeah, amazing. Makes perfect sense when I hear you saying it out loud, Michael. So it sounds good. Sounds good. And we're going to, with the 4 or 5 minutes we've got left, if it's okay with you, Michael, are you okay for 4 or 5 minutes?
4 or 5 minutes. I can.
Yeah, we will fire through some questions because we have been inundated with questions. So quite a good question here. Again, I think we have got a lot of people out there that are in the midst of building a career. So this question here that's come in is, how do you keep up to date with changes in the industry, because it changes so fast? How do you keep up to date with news, progress, innovation, latest technologies and stuff like that? Is it a never-ending battle? Have you got any tips for people that are trying
with difficulties? Keep up with, yes, it is never-ending battle, and yes, you have to read. Yes, you have to read and learn constantly. And here at Product Madness, we highly encourage people to learn. We highly encourage them to take modules on Coursera or any other online resources, even providing them with time to do so. I mean, data scientists have to learn all the time, constantly learn. You have to, in your yearly goals, you have to, this year I'm learning this year I'm learning that. There are several books which are obviously Bibles, but that you kind of, books by Tip Shirani are quite great. Statistical learning and statistical learning with arts, 2 great books. One is slightly advanced, other one is, but you have to constantly learn. You have to read. This is your job. This is what you like.
Amazing. Sounds good. Sounds good. Just as I'm picking out the next question, if you're watching along and have enjoyed it, by all means, do fire a quick message into the chat. It is nice to have a bit of a virtual round of applause. So it's always nice to see a few emojis or whatever pop into the chat just to say thank you to Michael for giving up his time. So that would be great if you can do that. In terms of the next question, quite a good question, actually, or very good question, actually. So question is, so in data, is data science not a role where there is more demand than supply? You seem to say that data analysts are more needed. I think over the years it's changed from what I've seen. 5, 6 years ago, very hard to hire data scientists. Now it seems to be you can hire data scientists, but finding good data engineers is very difficult. What's been your experience with that, Michael? Is there sort of demand and supply issues in terms of skill sets?
There are demand and supply issues in terms of skill set, but technically the one thing I know for sure is that hire a good person is always difficult. It doesn't really matter who they are.
Yeah. Doesn't matter what industry.
It doesn't really matter what industry is that, and if it's a data science or if it is whatever, no matter what it is. Finding the right match, cultural knowledge and everything else is always difficult. Be very rigorous in your hiring. Make sure that you're hiring person that you like and the person that likes you, because firing is much more difficult, stressful. and stressful and unpleasant. A, B, you can spend your time in the org which you might not like. So Don't just jump for any job. That's try to find the right match for yourself, and you will be needed, and you will make a great impact.
Perfect. I've seen people call that the plane test in an interview. You know, could you sit next to this person for 6 hours on a plane? You know, it's quite an important thing, isn't it, when you're trying to hire
it's
someone?
Actually, yes, you could see it in the Google film intern. I think if you can talk to that person, if you can see that the person on a plane. But then again, quite often computer engineers are people who just open their computer and they can sit anywhere with whoever it is, as long as they look at their computer. So that is always something one have to realize.
Perfect. I'm just going to fire through some of these messages, Michael, because there's been absolutely loads. So thank you, Michael, for the chat. I found it valuable to hear your insights. Phoebe, great session. Thank you so much, Michael. Thank you, Michael. Super helpful. Very enlightening conversation. Thanks a lot, Michael. Chris Bryant, thanks, Michael. It's always a pleasure to hear your insights. I would definitely agree with that one, Chris, for sure. Amit, thank you for the guidance, Michael. We've got clapping emojis. Thank you. Very interesting. Thank you. Very informative. Thank you, Michael and David. Good talk. This is one of the best, Dave. Thanks, Michael, for sharing your knowledge. So if that's not high praise, I don't know what is, Michael. And the list goes on and on, actually, man. So it's really nice.
Thank you very much, everybody. And I just try to say what I know, and I'm glad that people liked it, and hopefully we helped somebody today.
I hope so too. I'm sure we have, Michael. So just in terms of drawing things to a close, I know, mate, I really appreciate you being here today. I know you've had some stuff going on to be dealt with this morning. I know you professionally and personally, you've got links out to Ukraine, you've got staff out there, you've got family and all that sort of stuff. So I know you've had a lot going on. Just being here, you know, it stands out. It kind of shows your intent as a person, you know, sticking to it. We could have quite easily cancelled, which would have been fine. So just really appreciate you doing that, Michael. And you've been an absolutely awesome partner for the Data Science Festival. Great fun. The quiz was awesome. Today was awesome. I'm still keen to do that quiz again. So, you know, thank you personally. We'll do it again, man. So thank you personally, and thank you from my whole team as well. It's been great working with you, and thank you, you know, from the whole community really. So Jeffrey Payne's in the comments there saying what a great quiz it was. So it was good to know that Jeff made it to the quiz, man. So have you got any final words just to wrap up before we end the session?
So yeah, sure. I mean, you want to be data scientist, so be a scientist. Take it scientifically from the interview, from where you research about the company where you're going to work. Try to research, try to be a scientist from the moment that you decided to be a scientist, and then it all will be fine.
Amazing. It all will be fine. That's the end of the webinar. It all will be fine. So, mate, awesome. Thank you again, Michael. Thank you, Product Madness, and we'll be in touch soon. I'm sure we'll see you soon. And everybody else, thank you for attending, and hope to see you online and in person soon. All the best.
Thank you very much, David.
Cheers, Michael. Bye-bye.
Bye-bye.